The zero-day factory goes turnkey. The gap between security research and push-button offense closed another notch this week. A year ago, LLM-assisted vulnerability discovery was a provocative demo. Today, it is a documented pipeline with published false positive rates, and the tooling to act on its output ships is Docker containers. Ken Huang's comprehensive survey of LLM zero-day hunting lays out the current state. Google's Big Sleep found a real exploitable bug in SQLite. Anthropic's Claude Code security team claims over 500 zero days with a false positive rate under 5%. OpenIt's 5-stage pipeline. Static analysis, LLM reasoning, symbolic verification, dynamic testing, manual triage, reports 99.98% false positive elimination on a 120,000 function corpus. The Raptor hybrid agent chains reconnaissance, exploit generation, and validation into a single loop. None of these are theoretical. They produce working exploits against shipping code. The defense side cannot yet absorb output at that rate. The asymmetry is structural. Offense can parallelize across every function in a codebase simultaneously. Defense must still reason about context, intent, and deployment. The ratio will get worse before it stabilizes. Meanwhile, the tools to exploit what gets found are multiplying. Decepticon fields 16 specialist agents that automate an entire kill chain. From reconnaissance through lateral movement, inside Docker isolation, complete with generated rules of engagement documents. Red AI pairs a scanner agent with a validator agent and ships browser plugins for Chrome and iOS to confirm findings against live environments. Red Amon's SG React architecture, backed by a Neo4j knowledge graph, reportedly found 5 XSS vulnerabilities and a JWT secret leak in 1 hour of autonomous operation. Talon turns Claude Code itself into a penetration testing interface by connecting it to a Kali Linux VM over SSH MCP. Ask Claude to run Nmap, interpret the output, suggest next steps, and generate an OSCP-style report without leaving the editor. All of these projects emphasize authorized testing. All of them also ship with minimal access controls. The ethical guardrails are R, E, A, D, M, E paragraphs, not technical constraints. The architectural vulnerability that makes this worse sits in MCP itself. OX Security's disclosure identifies a fundamental design flaw in how MCP SDKs handle tool description injection, because the protocol trusts server-provided tool descriptions that get embedded directly into LLM context. A malicious MCP server can override system prompts, exfiltrate data, and hijack agent behavior across 10 distinct CVE patterns affecting packages with over 150 million cumulative downloads. Anthropic's response, that this is working as designed, is technically accurate and practically terrifying. On the other end of the sophistication spectrum, a Firebase user discovered a €54,000 billing spike in 13 hours caused by an unrestricted browser API key accessing Gemini endpoints. No abuse detection fired. Google denied the billing adjustment. The lesson is not about Firebase specifically. It is about the gap between how cloud providers market API keys as safe defaults and what happens when those defaults meet an adversary who reads documentation. When the silicon lies. CISPA researchers published a new transient execution variant against AMD processors spanning Zen 1 through Zen 5, disclosed as AMD Advisory SB7050. The finding came from TREVEX, a black box post-silicon fuzzer that runs attacker and victim processes on sibling SMT threads, flags cases where the cache footprint reveals more than one transient value for an architecturally single-valued operation, and does so without needing RTL access or an ISA emulator. A 25-hour campaign across 20 microarchitectures produced the result, on AMD Zen 1 through Zen 5, when a floating point multiply produces a result too small to represent. Catastrophic underflow. The CPU transiently forwards a non-zero garbage value to dependent instructions before the microcode assist corrects it. The original 2021 FPVI disclosure framed the trigger as denormal inputs. This new variant, which the researchers label VVI, reaches the same transient window through output underflow from normal inputs. The distinction matters for mitigations. Any defense that checks for denormal inputs will not fire, because VVI has no denormal inputs. Defenses that set MXCSR flush to zero globally still work. Mozilla's Firefox fix, masking NaN-boxed values at the boxing step, still works for the type confusion exploit class. But JavaScript core uses the same NaN-boxing architecture as pre-mitigation SpiderMonkey, and no public FPVI-specific mitigation is documented in WebKit source or advisories. AMD folded VVI back into the existing CVE 2021-26314, classified it as informational with no new CVE, and stated that existing mitigation guidance remains valid. That is accurate for the guidance as written. AMD recommended MXCSR FTZ plus DAS in 2021. It is misleading for the deployment reality, because many vendors implemented narrower mitigations tied to the denormal framing. The realistic exploit path still concentrates on JIT environments. The attacker supplies JavaScript or WebAssembly. The JIT compiles it to a vector multiply. The attacker picks operands near 1, 0, circumflex. 894, that guarantee catastrophic underflow and NaN-boxing type confusion turns the transient garbage into an arbitrary memory read. Catastrophic underflow does not happen in normal numerical code. Compilers do not emit it. HPC kernels operate orders of magnitude above it, and graphics pipelines set FTZ by default for performance. Whether a given JavaScript engine or WASM runtime is actually covered is now a code review question per component, not an assumed yes. The security community also paused to mark the passing of Felix FX Lindner, whose work with Phenoelid on IRPAS, the Cisco iOS shellcode, and HP printer exploitation defined an era when hardware and protocol security research meant building your own tools from scratch. The tributes from 30 colleagues trace a lineage from dial-up BBS culture through the professionalization of offensive security. A reminder that the field's foundations were laid by people who reversed firmware because it was there, not because there was a bounty program. Agents that rewrite themselves. The self-improving agent is no longer a thought experiment. This week's publications describe systems that modify their own strategies, evaluation criteria, and, in one case, their own weights during operation. Meta and UBC's HyperAgents paper introduces DGM HyperAgents, a framework where task-level and meta-level agents share a single editable program. The meta agent can rewrite the task agent's strategy, tool selection, and evaluation criteria based on performance feedback. Metacognitive self-modification across any computable task domain. The paper demonstrates cross-domain transfer. Improvements learned on coding tasks carry over to mathematical reasoning without retraining. The theoretical framing draws on Schmidt-Huber's Gödel machines, a self-referential system that only accepts self-modifications, provably improving expected future performance. NousResearch's Hermes agent takes a more pragmatic approach. It ships as a multi-platform messaging agent. Discord, Telegram, Slack, CLI, with a skill system that learns from interactions. 6 terminal backends, any model provider, persistent memory. The pitch is an agent that starts generic and becomes specialized through use, accumulating skills the way a developer accumulates shell aliases. Not through formal training, but through repeated successful patterns. A companion walkthrough demonstrates the local LLM variant using Honcho for dialectic memory management, consuming 496,000 tokens across a session while maintaining coherent context. Proof that self-improving loops do not require frontier model API budgets. Evo approaches self-improvement from the code side. An evolutionary optimization framework that uses tree search with parallel subagents in isolated Git work trees to explore solution variants, evaluate them against test suites, and propagate successful mutations. It is genetic programming applied to the agent's own tool implementations rather than to a target problem. The verification problem for self-improving systems is whether they actually improve or just drift. A detailed analysis of LLM-as-verifier techniques shows that fine-grained log-prob distribution scoring, combined with repeated verification passes and pairwise round-robin tournament selection, reaches 77.8% on SWE-Bench verified. The key insight: verifying a solution is computationally cheaper than generating one, so you can afford to verify many times and select the best. This gives self-improving agents a credible internal quality signal, the missing piece that separates productive self-modification from random walks. The incredible shrinking model. NVIDIA published a position paper arguing that small language models, under 10 billion parameters, are sufficient for agentic AI, not as a compromise, as a design choice. The argument: agentic workloads decompose into tool calling, planning, and domain reasoning steps, each of which can be handled by a specialized small model faster and cheaper than routing everything through a frontier model. Heterogeneous systems that mix SLMs with structured tool APIs outperform monolithic large models on latency-sensitive agent tasks. The paper catalogs LLM to SLM conversion techniques, including pruning, distillation, and architecture-specific compression, framing them not as degradation but as deployment optimization. The intellectual foundation for that conversion pipeline is Hinton, Vinyals, and Dean's 2015 knowledge distillation paper, which resurfaced in this week's discussions. The core mechanism: training a small student model on the soft probability distributions of a large teacher model rather than on hard labels, remains the backbone of every modern model compression technique. Temperature scaling during distillation lets the student learn from the teacher's uncertainty, not just its top predictions. The specialist model extension, where ensemble members handle different data subsets, prefigures today's mixture of experts architectures. ByteDance's in-place test time training takes a different approach to making small models capable. Instead of distilling a large model into a small one, it updates the small model's MLP block weights at inference time using a next token prediction-aligned objective. A 4 billion parameter model extends to 128K context with chunkwise weight updates that persist only for the current input. No retraining, no architecture change. The fast weights adapt the model to the specific document it is processing. On the inference side, a practical survey of 8 optimization techniques catalogs the current toolkit: quantization, speculative decoding, KV cache compression, page attention, turboquant calibration-free methods, flash attention, continuous batching, and structured pruning. The useful observation is how these compose. Flash attention plus page attention plus 4-bit quantization plus speculative decoding, applied together, can deliver 10 times or more throughput improvements on commodity hardware. The most immediately actionable result is from llama.cpp, a dynamic expert cache that keeps hot MOE experts pinned in VRAM and swaps cold experts from system RAM on demand. On QWEN3.5.122B with a 48 GB GPU, throughput jumps from 15.65 to 22.67 tokens per second, a 27% improvement from a caching strategy, no quantization required. The implication is that mixture of experts models, which were designed for training efficiency, can also be made inference efficient by treating expert activation patterns as a caching problem. World models and the shape of knowledge. Jürgen Schmidhuber published 2 companion pieces tracing the history of neural world models from his 1990 F.K.I. 12690 paper to the present. The historical claim is specific. The 1990 work introduced a recurrent neural network trained to predict environmental observations, used by a controller that plans action sequences by simulating outcomes in the learned model. The same framework introduced adversarial curiosity, rewarding the controller for finding observations the world model cannot yet predict, which Schmidhuber identifies as the structural ancestor of GANs. The LSTM networks developed from 1991 onward became the sequence modeling backbone that made these ideas practical. The pieces are partly priority claims and partly technical archaeology. The useful content for practitioners is the framing. A world model is not a language model with extra steps. It is a learned simulator that supports counterfactual reasoning, asking what would happen if rather than what usually comes next. Current systems like Sora, Genie, and DeepSeek's planning components are converging on architectures that look structurally similar to what the 1990 paper described, scaled by 6 orders of magnitude and parameters. Kurt Kegel's analysis of the ontology problem addresses the knowledge representation layer that sits beneath world models. The argument? Monolithic enterprise ontologies fail because they try to impose a single conceptual schema across organizational boundaries. The alternative is a federated architecture with internal models, how a bounded context represents its own domain and correspondent models translation layers between contexts. The parallel to REST API design is explicit. Semantic boundaries should work like service boundaries, with well-defined interfaces and no shared internal state. For AI systems that need to reason across knowledge domains, this is the practical alternative to training on everything and hoping the model figures out the relationships. Building the workbench. Anthropic launched Claude Design, a visual prototyping tool powered by Claude Opus that lets users create designs, interactive prototypes, and slide decks through conversation. The workflow. Describe what you need. Claude builds a first version you refine through inline comments, direct edits, or custom sliders that Claude generates on the fly. Teams can upload design systems, and Claude applies them automatically. The export path goes to Canva, PDF, PPTX, or standalone HTML. And when a design is ready to build, Claude packages a handoff bundle that goes directly to Claude Code. Brilliant reports that pages requiring 20+ prompts and other tools need 2 prompts in Claude Design. This is Anthropic expanding from code generation into the visual layer that precedes code. The Claude Code handoff is the strategic move, designed to implementation in a single tool chain, with the design system enforced at both ends. The competitive implication is that design tools like Figma now face a challenger that does not just generate mockups but connects them to the execution layer. If a prototype can go from conversation to code handoff without leaving the Anthropic ecosystem, the switching cost for teams already using Claude Code becomes very low. On the monitoring side, AbTop is a Rust TUI that does for AI coding sessions what BitTop does for system processes. It tracks Claude Code and Codex CLI sessions, token consumption, rate limit status, and orphaned ports. The observability layer that agent-heavy workflows have been missing. When your coding agent is consuming tokens at scale, you need something that tells you where the budget is going. CodeFlow provides zero-install codebase architecture visualization, dependency graphs, blast radius analysis, and security scanning from a browser. The value proposition is for teams onboarding to unfamiliar codebases, which is increasingly common when AI-generated code creates repositories faster than humans can read them. Deep Blue Dynamics shipped 4 self-hostable tools that address the infrastructure dependencies keeping users tied to cloud AI providers. Grub is an open-source web crawler. SHIVVR handles chunking and embedding without requiring local model downloads. Nemesis is a CLI orchestrator for multi-provider AI workloads in sealed Docker containers. Hyperia is an agentic terminal where multiple LLMs drive your machine while you stay in control. All 4 run in Docker on your own hardware, with Cloud Run as the convenience option rather than the requirement. The pitch is blunt. The AI industry's real product is lock-in, and these tools are the escape hatch.